Hello, hello. Thank you all for being here. We are back at it. Back at it once again. This will not be a 3-hour stream. At least I hope not. Don't want it to be. But let's just jump right in. I can't really think of anything to say in the opening or anything. So we're just going to get into it. Day 4. Day 4 of becoming a software engineer. Let's do it. I'm going to open this real quick. There we go.
So welcome back. We're going to continue and start talking about building our own functions. So again, we use the def keyword to define a function, and then later we're going to invoke this. And there's a bit to it. We are defining the name of the function. In effect, we're extending Python and creating new predefined things that we can use, except it's our code. It starts with a def keyword, has some optional arguments, which we'll see in a bit. That's what the parenthesis is. And then the name, and the function names follow the same rules as variable names. And then you have an indented block, whatever code you want to do, and then you have a de-indented block, and that sort of defines the essence. The key thing here is this is not calling. It's not invoking. It's not executing. It's remembering. It's storing. It's figuring things out. So here is the output of a program that defines a function.
Kind of logged out of my brain there for a second. Hold on a second. Print. Okay, so this isn't as being logged into the, yeah.
It's not invoking, it's not executing, it's remembering, it's storing, it's figuring things out. So here is the output of a program that defines a function but then doesn't use it. So this is a sort of broken function. So here we go, we start x equals 5, print. You don't have to you have all the defs at the beginning. The def runs whenever. So, you know, out comes hello. And then we define a function, and this says, oh, you want to make a new thing here. So I'll make a new thing. It's kind of like a variable in a sense. And then it copies this stuff, copies it up there, and says, later you probably are going to want to use this, so I'm going to remember it. So it doesn't do anything there. No output comes out. Then it says print yo, and out comes yo. And then it adds 2 to x, so x is now 7, and then it prints x, and there's no 7. There's 7. These print statements never ran. They never ran. Why? Because we did not invoke them down here. We defined them but didn't invoke them. So let's take a look at how you invoke a function, right? You define it and then you use it. Sometimes you define it once and use it once, but more commonly you define it once and use more than one time. Again, the store and reuse pattern. The def is the store and the invoking is the reuse. So here's just a slightly different version of that last program, and so now it's going to actually invoke it. So x equals 5, print hello, def, so out comes hello. This produces, the def produces no output, right? But because there's a de-indent here, that is the entire blob of the code that is part of print lyrics. So it prints out yo, and now we're going to invoke. This is the call. We're going to call the function. Now the function goes up. Let's clear this. So we're down to here. Now this like suspends at this place. It's like remember to come back to here when we're done. Go up, run this code, and then come back, and then continue on. So it like leaves like a breadcrumb of where it's supposed to come back to, and then it runs. And then the print lyrics, of course, produces the 2 lines of output. And yeah, that should probably not have. That day should be up there. And then x equals x plus 2, which makes it 7, and then prints out 7. Okay, so this is the invoke or call the function. Okay, you defined it, and then later you called it. Now, in addition to just call and return and invoking, we can pass parameters in. And the example of the parameter is in the max function, we have to say, this is the thing I want you to find the maximum of, the largest thing. And part of it is in the whole store and reuse pattern, we have a few lines of code, but sometimes we want to do ever so slightly different things in the different invocations. And so we use the arguments to subtly adjust, like finding the maximum is a general thing, but what thing to find the maximum of, that makes a function that's much more useful and reusable in a lot more situations.
Oh.
So
Okay. Yesterday I was a little confused about arguments. Let me go through this again. An argument is a value we pass into a function. An argument is a value we pass into the function as its input. When we call the function, use arguments so we can direct the function into different kinds of work. Oh. We put the arguments in parentheses around after the name of the function. Okay. So that's the argument.
Arguments are the thing we passed in, and we define for our functions that we're going to build, we, on the def statement, so we say def, greet, name a function.
Parameter is a variable which we use in the function definition. There's a handle that allows the code to access documents for a particular function. Invocation. So it'd be this then?
And then this is the arguments, the things that are coming on the def statement. So we say def, greet, name a function, and then this is the arguments, the things that are coming in. Now, this lang variable, in a sense, only exists during the life of the function, and it represents sort of a placeholder. It's not a real variable in the same sense. It's a placeholder that refers to how you touch that first parameter that's sitting in there. Okay, and so lang is our first parameter, whatever it is. We don't need to see this part down here right now. All we know is we're going to make a function, and we're going to take a parameter, and this lang is the placeholder that tells us what that parameter is. Okay, so within the function, we're going to check to see if the language is Spanish. If we are, print hello. Else, if the language is French, print bonjour. Otherwise, print hello. We have a very highly simplified language translation system here. So the def, of course, does nothing except remembers that and defines the concept greet. So that comes down, and now we're going to call it. And that says, go look up the thing that I defined called greet. If you
Oh, cool. So greet en, and it'll come down and oh yeah, so en isn't defined here, so we'll go to hello. Es is, and so hola, fr, bonjour. I'm still kind of confused about what parameters are. So this is the function definition. Allows the code in the function to access the arguments. So it's not the arguments. It's probably greet, right?
If you don't put this in, greet is going to give you a traceback, but because you extended and named it greet. So it runs in, it starts, suspends the code here, starts up here, but then lang is now an alias to en. So now we can run if that alias is yes.
Remember that you from yesterday?
No, else if, I'm getting it all wrong now. Right, so en comes in as lang, we're coming in the code. If it's not es, it's not fr, else it prints hello, and then it comes back to the next line. And then we call it again, and this time es is lang, and so it runs this code and prints hola, and then next time it calls with this, and then it prints bonjour. You get the idea. So this is a placeholder so that on the successive calls or invocation of the function, we can get at whatever the programmer put in as that first parameter. And so we are saying in this definition, we are ready to receive a first parameter. Please call us with a parameter and then we will be able to do something slightly different for the different values. So this is a reusable bit of function that prints hello in 3 different languages, and then we tell it what language at the moment that we're actually invoking it. So that's putting stuff into the function. Now getting stuff back out is the...
For the parameters, I'm going to let that slide for now. I'm not 100% super solid on what that is, what they are, but I'm not going to stress about it right now.
The concept of returning. In the return statement is an executable statement that does 2 basic things. The first thing that it does is it finishes. Now this is a 1-line function, so that's kind of redundant, but when Python goes into the return statement, it doesn't continue on to the next line. It just returns. That is the end of the invocation of that particular function. But even more importantly, it takes as its parameter. You can say return without a parameter, and it will stop the execution of the function, kind of like a break does for a loop. It's kind of a break for a loop. Get out, we're done. Don't run that next line, get out. But it also allows the specification of what you want as the residual value in an expression. So we're doing a print, and then we're saying greet, and what's going to show up here is whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay? And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. The return statement...
What I'm confused about is that how did we get... Oh. So hello is the beginning bit, and then print greet, which is hello Glenn, greet, hello Sally, hello Sally.
But it also allows the specification of whatever this function does in its return statement. And so that prints hello. We call it again, and it prints hello again. Okay? And so basically the return statement is I call this the residual value. It's like what shows up here when the function is all done, and it's the string hello. We call the functions that return values fruitful because they produce something, but you don't have to. You can just say return, or you don't even have to have a return statement. It goes to the last line of the function, and it does a return automatically at the last line of the function. So here's a little bit of a rewrite of our little language program. We are going to create a greeting program. We're going to take the language as the first parameter. And instead of just doing a print statement, which is what we did before, this is now more like a function because it takes some input and produces some output as a return rather than just printing. It's a little tacky for a function to print. And so here we return hola, bonjour, and hello based on the right thing. So now we say print greet en, so it runs the code once, lang is en, and then it runs this code, and the residual value is hello, so it says hello Glenn. And similarly, when it runs this code, it passes es in as lang, it runs through, and it runs this statement. It does, if there was more statements, it wouldn't run them as soon as this return runs. That says that this bit right here is now HOLA, so hola Sally. And the same with French, goes in, runs again, out comes the return statement, and then bonjour Michael. So you see how we can control as we're writing the application, we can control as we're writing the function what the residual value that we want to see in whatever expression is calling us. Sometimes we have returns and sometimes we don't have returns. So if you think of the max code that we talked about before, we can kind of see that somewhere inside that max code there's a return, and that's how it communicates the W back to us. So we pass in as argument, hello world. It comes in as a parameter, and it's going to loop through this imp somewhere. It's going to loop over and over into...
Wait, so I thought that was an argument.
So we pass in his max code that we talked about before. We can kind of see that somewhere inside that max code there's a return, and that's how it communicates the W back to us. So we pass in his argument, hello world. It comes in as a parameter, and it's going to loop through this imp somewhere.
Oh, so the parameter is kind of what arguments are. They're kind of, in a weird way, the same thing. So the parameter is the what you put in, but then what you actually put in is the argument. If that makes sense. Print big.
It's going to loop over and over into imp, and then at some point it's going to figure something out and tell us what it wants to send back to us is a return statement, and so the W comes back and gets assigned into big. You can have more than one parameter, and they're just in order. The first one and the second one, 3 and 5. So 3 becomes A and 5 becomes B, and away we go. So we just use this to add two numbers, and so 3 plus 5 is 8.
Okay.
So you get as many as you like, and the order matters. And if you do things like you tell it you want parameters and you don't give it to them, then that'll become a traceback, and it'll blow up. You can also talk about optional parameters later.
Really?
So you don't have to have return values, and that means that you simply don't call a return with a value, and return is always implicitly happening as the last line of the function. So that's kind of the basics of how functions operate, but I don't want you to get too excited about writing functions. Some programming classes are like, gotta write a function, gotta write a function. Functions, to be clear, are a very powerful mechanism. And as we write programs, 150, 200,000, 200 lines of code, 1,000 lines of code, 10,000 lines of code, the concept of a function is really important. We would go crazy if we didn't have functions. But if you're only writing 20 lines of code, forcing yourself to write a function is kind of pointless. So don't worry about maybe the lack of urge to use this. We are calling lots of predefined functions, and we will for the next couple of lectures. There will be a time when you go like, oh, I'm sick and tired of repeating myself. Oh yeah, time to write a function. So that's why we don't push functions prematurely. We just want you to know what they are, use them, and at some moment you'll be like, oh, I want to define one. But don't worry about, it might take a while before you really want to define a function. So that kind of summarizes our lecture on functions, and up next we're going to do iterations.
Heyo. Sorry, I kind of burped into the mic a little bit. Sorry about that. Sorry.
Hello and welcome to Python.
Okay, so there's our exercise. But before we do that, what will the following Python program print out? So define Fred, print Zap. Define Jane, print ABC. So ABC, Zap, ABC, ABC, Zap, ABC. Hey, yo, move it on. Nice. No exercises. That's always great. Okay. Depending on, I don't know what the exercise is going to be. We may just do it along with them. I'm a little tired tonight. I don't want to do this too long. But
For everybody, this is another of our worked examples, and I'm your instructor, Charles Severance. So the example we're going to do right now is exercise 4.6 in chapter 4. This is an exercise where we're kind of taking code that we've already written and redoing it in a way to just prove that we can do it with a function. So it's not like it's going to do anything different. It's going to do exactly the same as before, and we're just going to do it a different way. So let's go ahead and start up our text editor, Atom. Show you a couple new features of this. It's already been opened. Let me sort of open it here again.
Frick, I was in it the whole time. Can I just... I should do it. Okay. Let's just take a moment. So, shoot, I don't even know. Define function. Let's just follow through. And what we might do what this person did, pause at the end.
I'm going to open, get a new window, and then I'm going to open. But what I'm going to do is to open this folder, right? So it's this folder right here, and I'm going to open that. So instead of opening a file, which is what I've been doing so far, I'm going to open a folder. So now you can see all the folders that I have, and they're just exactly the same folders that I've been making under desktop py4e. And so I can go and look at my previous assignments. The other thing I can do is I can control click on this and say new folder. And I can say EX exercise 04, 06. Again, I like the 04 and the 06 just so things line up when we get to chapters 10 and 11. That's why I'm naming my files this way. And I'm going to adapt exercise, the code from exercise 3.1. We could do exercise 3.2, but it's longer. The difference between 3.1 and 3.2 was one uses try except and the other one does not. So I'm going to try to start with this one. I always clean up and get rid of that. So here is our time and a half for overtime logic. And I am going to say file save as. So I'm making a copy of it. And I am going to put this in this folder exercise 4.6, and I'm going to make sure to rename my file 0406. Okay, so now I've got exercise 0406, which is this one right here. That's the file we've got, and it's there. And so let me pop up my terminal window, cd desktop, cd py4e, cd ex04. Hit the tab for 06 because there was only one in 04. And so I can see where I'm at, and I have one file here, ls. -l gives extended information. And I can say Python 3 ex04 py 10, 10, and away we go. Okay? So this is this code. I'm going to get rid of some of this logic here. Just these print statements, which I commented out, just to make it a little more dense. Okay, so let me start by just putting a function in here. And of course, def is the keyword for function, and compute pay
I don't need a colon.
is the name of the function, and it's supposed to take two parameters, hours and rate.
Okay, I was gonna try and no, you know what? Let's try this. Right? Okay. Even though ours is still using the try and accept version. Def compute pay hours rate.
And then you add a colon, and then we're indented, right? So the indent is to determine how long the function it lasts, how many lines it is. And I'm just going to say print in compute pay.
In compute
Give
pay?
myself a blank line. I'm going to save that. Now, I'm going to run it now.
Scared.
I'm going to run it now, and you'll notice something real quick. this line never came out. And that's because the way this works is this simply defines the function and then it continues running, but it doesn't run that code. And it ran this code, and then it did, in this case, the else code, and then it did the print. But it never came up and actually ran this code. We have to call the function. Okay, we have to call the function before it's going to actually run. So now let's make a call.
Okay.
Compute pay.
So what's it going to do? This is going to be down here. I love giving things spaces, man. Just helps me stay organized. Compute pay, and then we need to put in output hours and output rate. Watch. Hours. So output rate. Output hours rate. Watch.
And let's pass in our variables that we have in this main code, FH and FR. So that compute pay FH and FR, and then I'm going to print out hours and rate.
Okay, that part's a little confusing, I'll be honest.
So now you'll see it's going to do the input, convert to floating, call the function, which is going to run this one line, and then continue down here. All right? So now what it's going to do is going to define it, run this, call compute pay, which is going to temporarily suspend, come in here, run this code, and FH is going to map to hours, and FR is going to map to rate, and then it's going to come back, and then it's going to continue down here, running this code and then finishing. Okay, so that's what's going to run. So this time we will see compute pay, and we will see the number for hours and rate.
Still works, so that, I mean, that's good. Oh. 10.
So I'll run it again. 40 hours, $10 an hour. We see a mistake.
What?
I'm like, and then you're going to see the word compute pay here.
Wait, no.
And I'm like, okay, that didn't happen. Well, what's going wrong? And we will see the number for hours and rate. So I'll run it again. 40 hours, $10 an hour. We see a mistake. I'm like, and then you're going to see the word compute pay here. And I'm like, okay, that didn't happen. Well, what's going wrong? Let's take a look at what's going wrong. I don't plan to make these mistakes. I just make them. Let me show you what's wrong here. See this little blue dot?
Saved. He didn't
That's
save
what's
it.
wrong with my code. And if you don't catch that, then you'll say, oh, I'm crazy. Well, I'm not crazy. I just made a mistake. I forgot to save it. File save or Command S. So now I saved it. I didn't change a single line of code. It was right. I forgot to save it. So I'm going to run it again now. 40 hours, $10. And look, now I see this line. So it came into compute pay and then came back and then finished this part and did compute pay. Okay? Now, this isn't enough. What I need to do is I need to move this code, the actual pay computation. So I'm going to cut that and I'm going to put it in here.
No, crud. Why? Oh, see, ours is a little different though. I mean, honestly, can we just do the whole thing? I'm scared, bro. Oh, I'm scared. Oh, I'm scared. That won't work. Yeah. Because we gotta define it first as an integer. So ours is a little different. But why is this though?
But now this variable fh belongs to the main program. It doesn't belong to this code. Now I don't want to use that. So I want to say hours. So I'm taking whatever hours are being passed in and then using rate.
Okay, let's try it though. But it's still not defined as hours. Or it's still not defined as an integer.
And I'm just kind of changing all of these to match the parameters inside the function. This is hours.
This is
and this is
clean
rate.
code. Because, like, why couldn't the other way work?
And this is hours. And this is rate.
But it's still, you gotta define it, bro.
Now I'm going to print a print statement inside. I'm going to say returning. And then I'm going to print XP. And then, still inside the function, I want to return a value from this function. So I'm saying the returned value for this function is actually in the current function variable XP. And then I'm going to call, actually I'm going to not call this XP, I'm going to call this pay in here. Oops, not with capital. I don't want to be capitalized. Pay and pay and pay. So it's returning pay, and then in here I'm going to say XP equals compute pay. So what we've achieved here is, let me get rid of that. What we've achieved here is it's going to come down, define a function, then read the input, convert it to floating point, and then call compute pay, passing in FH as hours and FR is rate, right?
Compute pay, XP. Ooh, this is a little weird. Let's try it though. Again, I'm scared. Bump the else up. Freak. Hours is better than greater than 40. Rate. Rate. Leaving the overtime rate as it is. It is going to be hours. This is going to be rate. Okay. Should work. So this defines the function. I have a feeling it still won't work though. For oh. Line 7. Yeah, no, that's fine. It works. Okay, so this is the whole function. It grabs hours. turns it into an integer. Grabs the rate, turns that into an integer. Then it takes OH. This is bonkers, man. Hang on with me. Hang on. So OH, which is put in right here, right, for the hours, and OR, which is put in right here for the rate. For the first one was for hours. The second one was for rate, hours rate, and it plugs in hours and rate because that's oh man. Then it runs it down here. He's got to follow it, man. It's confusing, but it makes sense.
And then it's going to take hours and rate, do whatever it does with the if then else. It's going to print these things, then it's going to return it, and then whatever this pay variable is effectively goes back into this expression as the return value and again gets assigned into XP. Okay?
We didn't do all the XP
so that's
stuff.
basically what's going to happen, and then we'll print, it'll come back and then print XP. Okay? So let's go ahead and run. Oh wait, I almost did it again. Look at the little blue dot. You guys can watch the blue dot, and when I forget to save it, and when I then run it, it'll blow up. So $10 an hour, oops, 10 hours, $15 an hour. So now it worked. So you can see these two print statements come from while this is running. The input happens, it calls the function, and then it prints out the pay. And now to finish this, to get it right, I will simply comment out my little helpful debugging print statements and run it one more time, 40 hours, $10 an hour, and run it again and have it be $50 an hour and 50 hours and $10 an hour, so 550. So that one is now working. So that one is completed, and we have moved our computation inside of the function. So I hope that you find this useful. I hope that you find this entire course useful, and thanks for watching.
Woohoo! Pretty painless. Yeah, so we didn't do the compute pay or XP or whatever, like the debugging stuff that he did, but hopefully that's okay. I'm going to run this one more time just to kind of see something here. 40 or 50, excuse me, hours. 10. That is the right. Yeah, that's the right one. Correct me if I'm wrong. No, that's right. I'm just overthinking. Like the OCD sort of like, is it really right? No, it should be right. Cool. Moving on up to the side.
Hello and welcome to Chapter 5, Loops and Iteration. Now we're going to work on our fourth basic pattern of sequential, conditional, store and reuse, and loops and iteration. And this is the one where we teach the computer how to do things a lot. We can tell it to do something a million times. And so that's where we get the doggedness of computers, or the fact that they're so good at doing work for us because we can set them off to a task and they'll do it until it's done. So here's a very simple loop.
These are cool.
Coffee over here. The keyword that we're going to start using is the while loop. We're also going to use the for later on. And the while loop functions very much like an if statement. The while starts it, and then this is just like an if statement. It's a question that leads to a true or a false answer. And then there's a colon, and then there's an indented block, and then we use the de-indent to determine how long the loop is, and so this print is de-indented, so that indicates the end of the loop. And so at some level, what's going to happen here is it's just going to run, and if this is true, it's going to run this code, and if it's false, it's going to skip the code. In that way, it functions like an if. The place that it doesn't function like an if is after it's run the code once, it goes up and then asks the question again. And so you can think of it going back up kind of to the top of the while loop and then re-asking the question, like, okay, is this going to run again? And then it's going to do that some number of times, and then it's going to finish. And so that's the loop, that's the iteration. And we're going to make a variable, we're going to construct very carefully a variable that we call the iteration variable, and that's n. And it's a variable that's going to change, and it's our way of running the loop, but not running the loop forever. So let's just run this. We come in, n is 5. Is n greater than 0? Yes, it is. So we're going to run this code. So we're going to run this code. We're going to print out 5. Then we're going to subtract 1. And then we're going to go back up and ask the question. Is n greater than 0? And the answer is, since it's 4, the answer is yes. So then it runs again. Then it prints out 4, subtracts it again, checks, prints 3, subtracts it again, prints 2, subtracts it again, prints 1, subtracts it again. Now n is 0, and so it comes back up. Is this question has now become false? So it's going to take the exit. So it's going to come down and run this line right here. Then it prints blast off, and we can kind of print out the residual value of n just to sort of prove to ourselves that it ran until n was no longer greater than 0, and then 0 was the final value for n. And we carefully constructed this n equals, oops, go back. We carefully constructed n. We set it to 5. Then we carefully subtracted 1 each time through the loop. And then we're using that to control when to exit the loop. And so you could think of this loop as, for now, running 5 times, true, 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 and then false, finally. So this question was true for a while, and as long as it was true, the loop ran. And then when it turned false, the loop stopped. And so this variable that we construct to control the loop was called the iteration variable, because it tells how many times this loop is going to run over and over, or otherwise known as iterate. So this is a badly constructed loop with an iteration variable that we didn't do very well. And so if we take a look at this, we start out with n5, and then this is greater than 0, so it's true, so it runs it, and then it runs it again, and n is still greater than 0. So you can pretty much see, because we're not changing n, this is going to be true, 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 dot, 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 forever, true forever. And so this is an infinite loop. And it's just going to run until your computer runs out of battery, or you hit the button. This is the kind of thing where you often see your computer spinning like a spinning beach ball, or some other indication that your computer's super busy. It's in some kind of a loop, really tight, and it's running something, and it's using up all of the processing resources of your computer.
A little scary.
That's an infinite loop. And so the problem is we did nothing with the iteration variable. Now here's a different loop. And so this one demonstrates a different idea. So in this case, we start out with n is 0, and it comes in here, and is n greater than 0? Question mark, and the answer is false. So it skips it. It doesn't run these lines of code at all. And so this loop doesn't run at all, because it comes in, asks the question, it says no, and then it skips right around it. So never run, never run. And so this actually is, sometimes you write a while loop on purpose like this, not quite as simple as this one, but the idea is this emphasizes that these loops are what we call zero trip. They are not even guaranteed to run once. They're going to run maybe 0 times. And in this respect, it functions exactly like an if statement, right? Meaning the first time through the loop, if it's not true, it's just going to skip right by it.
What do you say about an if? It's basically an if?
In fact, it functions exactly like an if statement, right? Meaning the first time through the loop, if it's not true, it's just going to skip right by it. So there's a couple of ways of getting out of loops. In this case, I'm constructing an infinite loop, because remember the kind of definition of an infinite loop is if this is going to stay true. Well, true is the constant true. So this is going to run forever. And what it's going to do is it's going to prompt with a little arrow, and then let us type and read whatever we type into the variable line. And then if the line is done, we're going to break. Now break is an executable statement, and if you hit the break, it exits the innermost loop out to the place beyond the end of the loop. So when this runs the first time, and we say hello there, line is not done, so it prints it. So it prints out hello there, and then goes up, And then we type in again, we type finished, and so it's not done, so it prints it. So now comes that print statement. And then we type in done, and now this becomes true. And it comes out and runs the code beyond the end of the loop. The key is it doesn't go back. It's like once you've done a break, that loop is done. And so you look at basically, the block that is the loop. So here's kind of the loop block. And then the break goes to the line after the end of the loop block.
I get it.
And you can think of this as sort of like just a hyperspace jump. There is nothing really, this could be literally hundreds of lines with if statements, and you could be running and doing all kinds of stuff and running and doing all these things, and these things could run all kinds of ways, right? The point is as soon as you hit a break statement, however much stuff is down here, however much stuff is up here, it exits to whatever the next line is beyond the end of the loop. Continue is another loop control statement, but it works differently than break. So break says get out of this loop. Continue effectively says stop this iteration. We're done with this iteration. And so continue says go up back to the top of the loop. Oops. Yeah. Go up back to the top of the loop. And so here we read a line. If the first character is a pound sign, line sub 0, if that first character is a pound sign, we're going to skip it. And this is a way for us to make like little comments in our typing. And then we print, if the line is done, we get out, and otherwise we print it. And so that's why there is no printout here, because it comes in, runs, it comes in, this is true, and that goes back up. But it comes back and prints out the next one and does another thing. And so the loop continues, whereas the break ends the loop. And so again, the same kind of notion that you're sort of doing all kinds of complexity. Wherever you're at in this loop, you hit continue, and it doesn't go any further. It goes back up and runs the question mark. It asks the question mark. And so, asks the question, and it might exit the loop in that particular case. But this one here is this is an infinite loop that I've constructed. This is not an infinite loop because at some point the break gets us out of the loop. And so it's an infinite loop with break to escape it. And that's another common way to construct a loop. So these loops that we've been drawing so far, the ones that use while as their keyword, are what are called indefinite loops. And that's because they kind of go for a while, till a break hits or until some value becomes true. As long as that value remains true. So all the ones we've done so far are easy to look at and know that they look pretty good and they're probably going to finish. But there are sometimes, if they're long and complex and their exit or termination conditions are a little more complex, it's not clear that they're really going to terminate. And so we can use while loops for a lot of things, but for most of our looping, we're going to use what are called definite loops, and that's what we're going to talk about next.
Definite loops. I like loops. Loops are pretty cool. Okay, what will the following code print out? So, n equals 0. While true, if n equals 3, break, print n. Okay, so if it's 3, break it out of the loop. So right now, n equals 0. At the beginning of this code, right when you run it, n equals 0, which means it's not 3. So it's going to print 0, and then 0 plus 1 is 1. Sorry. So that is it's going to change, so it's going to be 1, still not 3. So it's going to print it, so 0, 1. So this one, right? Because it once gets to 3 while true, if n, it's going to break it and not. Oh, wait. Oh. It won't print if it's 3. 0, 1, 2. feel me on this? Yes. Please don't have exercises. Yes. Okay. Okay. Cool. Fun fact. Tomorrow, I looked back at our Python course. Tomorrow, we are going to be catching up to where I was before and going past it. So it'll be new ground for me. When I have been watching it again through this time, I've just been letting like the slides go for most of it. I've paused on some of them, but when we catch up to where I was, and get past it, I'm gonna pause it on basically each slide. I am gonna pause on each slide probably, just to kind of take it in. You know what I mean? Understand it, so he like then focus on what he's saying, because I don't want to be trying to do both and then miss something, one or the other. So FYI, last video.
So definite loops use the for keyword, and the idea of a definite loop is it's going to loop through some set of things. It might be a set of lines in a file, it might be a set of characters in a string, it might be a set of strings in a list of strings. But whatever it is, it's sort of going to run a finite number of times depending on the thing that it's looping through. And we like this. And it's an easier way to construct it, and we actually don't have to deal with the iteration variable. The for loop includes a mechanism to construct the iteration variable for us. So it's definite loops iterate through the members of a set. So here's a very simple for loop. And so you see the for keyword, and in is also a keyword.
I'm sorry. Let me back up again. My brain kind of jumped to some editing stuff I have to do tomorrow. I'm sorry.
String, it might be a set of.
I'm sorry.
So definite loops use the for keyword, and the idea of a definite loop is it's going to loop through some set of things. It might be a set of lines in a file, it might be a set of characters in a string, it might be a set of strings in a list of strings. But whatever it is, it's sort of going to run a finite number of times depending on the thing that it's looping through. And we like this. And it's an easier way to construct it, and we actually don't have to deal with the iteration variable. The for loop includes a mechanism to construct the iteration variable for us. So it's definite loops iterate through the members of a set. So here's a very simple for loop. And so you see the for keyword, and in is also a keyword. And the iteration variable is something we put right here. This I is declared. This I is like an assignment statement. And I is going to take on successive values. So I is going to be 5 the first time through the loop. Then I is going to be 4 the second time through the loop. 3, 2, 1. So I is going to be assigned 5 different times to 5 different values. And then the loop is going to run. It's going to run once with 5, once with 4, once with 3, once with 2, and once with 1. And so this block of code, we have contracted, say, execute it 5 times, with these values of I. I is that iteration variable. I is the thing changing through each iteration of the loop, okay? And so that's why this prints out 5, 4, 3, 2, 1, and then when it's done, it finishes it. And so this is a much more direct syntax for looping 5 times and setting an iteration variable. You kind of all combine it into this one thing, right? All into one thing. So it's quite nice. So you don't have to be going through a list of numbers. There's all kinds of things that we can iterate through with for. And by the way, while I'm sitting here, I named my variable friends, because that's a list of strings, and friend, which is the iteration variable. I'm using singular and plural because it helps you read it. Python doesn't understand singular and plural. So just because you say friends doesn't mean Python knows it's a list. Python does know it's a list, but it doesn't know by the name of the variable I've chosen. That's your basic mnemonic variable warning. These are cool variable names, but I don't want you to be confused by them. So you can loop through a variable. So we're going to take this list of 3 strings and stick it in friends. And so friend is going to iterate through that. So the first time through, friend is going to be Joseph. Second time through, it's going to be Glenn. Third time through, it's going to be Sally.
Wait, I'm confused here. So, okay, friends. Friends equals. Okay, so this is separate than the definite loop thing. Friends is different. It's like defining the list, right? Friends. For friend and friends. Okay, so then this kind of determines, so it's as print Happy New Year, friend. Friend, friends is the list, so Joseph, Glenn, Sally. A little weird, but we're going to continue.
And so that just says run this loop, run this code, the indented code, 3 times. Each time the variable friend takes on a successive version of a successive value that's in the friends array.
Okay, yeah.
So it says happy birthday Joseph, Glenn, Sally, and then we come out of the loop and we print done. So
I feel like the way he did that was a little confusing. I don't know a better way to explain it, but I feel like he did it in a kind of confusing way.
If we try to draw a picture of what this is really doing, the for loop is actually doing a whole bunch of stuff that we would have to do with maybe separate statements in the while loop. First, it decides how many times to run the loop, so it's answering the done question, which way do we go? And it is also then moving I ahead. It's managing the iteration variable. If you go back to it's initializing it too. If you go back to the while loop, we had n equals 0, while n greater than 0, n equals n minus 1. So we had like 3 lines to control the loop to manage the iteration variable. But with a for loop, we don't have to do that. And so that's all taken care of. And so that basically says, you know, it's initializing it to a loop. First, it decides how many times to run the loop. So it's answering the done question, which way do we go? And it is also then moving I ahead. It's managing the iteration variable. If you go back to it's initializing it too. If you go back to the while loop, we had n equals 0, while n greater than 0, n equals n minus 1. So we had like 3 lines to control the loop to manage the iteration variable. But with a for loop, we don't have to do that. Oh, okay. And so that's all taken care of. And so that basically says, you know, the for loop, by you using a for loop, are we done? No, we have 5 things to work. Well, set I to the first one, run it. We're not done because we got one more. Set it to the second one, third one, fourth one, fifth one, and now we're done. And that is all handled in a single line of code that includes the iteration variable and the set of things through which we are going to iterate through. I really like the word in. It is mathematically, it reminds me of the set theory where you say this is a member of this set, or the for each. Math isn't important here, but if you do know math, the vertical bar means such that, right, is a member of this set, and that kind of stuff, member of this set. I'll erase the math stuff so we don't over math. But it's like for each of the values in the set 5, 4, 3, 2, 1, run this loop setting the iteration variable I to the members of that set. So in reminds me, for those of us who are math oriented, in reminds me of a really nice concept in mathematics. Okay? Now, you could think of this as sort of this looping structure where the for loop, and this is pretty much how it actually runs inside the computer, right? Where it initializes it it runs this thing 5 times, and then executes. That's one way to think about it. But you could also think about it in a somewhat more abstract way, and think of it as all we're really doing is we have a contract with Python that says we're supposed to run this code 5 times, and I is supposed to be 5, 4, 3, 2, and 1. So you could imagine this might be what's going on. The for loop sets I to 5, runs our code. The for loop sets I to 4, runs our code. The for loop sets I to 3, runs our code. The for loop sets I to 2, runs our code, for loop sets I to 1 and runs our code. All we know is our code was ran 5 times, and by contract, each successive time, we're get a different value for I, and the value for I is taken from this set. And so this is just one way to think about it, to say to yourself, oh yeah, this is one way to think about it as it's actually, and this is how it really works. But this is also kind of logically the contract that Python is making for us. So up next, we're going to talk about taking this notion of doing something to a lot of items, but accomplishing something with that. And I call these loop idioms.
Loop idioms. So this will be easy, right? For I in 215, print I. How many lines will be, or will the following code print? 1, 2, 3. Nice. Excellent. Okay. So, that is going to do it for today, I think. About an hour. Hair over an hour. Hair over an hour. I do want to briefly practice what you've learned. Let's get this, so I'm in here, right? This is hacker rank. I also want to get into leet code. Whoops. Fun with arrays. Whoa. Have I never been to leet code? I'll need to look into this. I will need to look into this. Introduction, inserting arrays. But let's try something here. Here's a sample line of code that can be expected in Python. Print hello world. You can just as easily store a string as a variable and print it to that. My string equals hello world, print my string. The above code will print hello world on your screen. Try it out in the editor below. Oh, info format. You do not need to read any input in this challenge. Okay. I'm freezing up. I think this is it. Whoa. No. I want to get this one. Dang it. I don't know anything. If mat equals. Can I change the whole? I can change the whole thing. But I could just repeat it though. It's like cheating, right? Okay, is it even possible to do code with an if statement that's just 2 lines? It needs to be defined. Wait for it. I don't know if this is what they want me to do. Wait, no, this needs to be... If mat equals print message. Guess what? It does. Kind of went my own way. Should work though. I should have run it. Can I run it? What? Did I spell it wrong? What the deuce, man? Mat equals print message. We're just fine. We'll do it this way. Print string. Yay. Was I thinking too hard? Oh. Whoa. Frick. What'd I do? Give me it back. Okay. I don't know what this is. Cool. I did it again. Summation select report. Can I like back up? How do I move on to the next one? Is it just taking a while? Oh. So what kind of next challenge do we got here? Let's just see. We're not going to do this one, but we're going to see what's up. Given an integer. What the heck? What is that? N? Okay. Perform the following conditional actions. If n is odd, print weird. If n is an even, an inclusive range of 2 to 5, not weird. That's the inclusive range of 6 to 20. Print weird. Or no, 6 to 20. Print weird. So if n is odd, print weird. Oh my word, bro. A single line containing a positive integer. Constraints. Bro, I don't even have a clue. If name. Can I skip this one? Can I skip it? I don't know this one, bro. I don't know this one. Oh my gosh, wait. Test your knowledge using if-else conditional statement to automate decision-making process. Oh, it's easy, good. That didn't really help me. That was just like a here's a diagram. Needs to be something like if. I think I might actually be able to do this if given enough time. If I don't know how to do the odds or evens though. If n equals because I'm guessing Python doesn't know what an even number is, so we need to tell it. If n equals like, well, okay, so if it's odd, it's like 1, 3, 5. Ugh. That does not help me. Does it give you code? Does it give you the code? It doesn't give you the code. It's probably for the better. I mean, see, what hangs me up is I don't know if this is needed. I don't know that it is. Because we just want an output. That's weird or not weird. I feel like I kind of want to mess with this. Not now, but I feel like we could probably do this. I'm excited. Cool. All right, that is going to do it for today. Hold on. There we go. Thank you guys so much for watching today's humble stream of 1 hour and 17 minutes. Not 3+ hours like yesterday. Got some good stuff in today. Tomorrow is Friday, and I might I don't know when I'm going to be streaming. I don't know. It might be later. It might be later, like it has been. One of these days, I think next week. I might try and stream during the day. Believe it or not. We shall see. I don't know if I'm going to be streaming during the weekends. Especially Sunday. Maybe Saturday night. Not sure about Sundays. Probably not Sunday. There was ever a day for me to not worry about this, it'd be Sundays. But we'll see. Thank you guys so much for watching. Please leave a comment if you'd like me to be praying for you guys for anything. Please like and subscribe as well. And I will see you guys tomorrow.